Okay, and this is where we left, and now we're gonna continue with part 2 of our assignment. And the first task will be, well, actually we have all these different features here. So this is, we can select it. This is one. We have to select this one. This is one feature. This is another feature. This is yet another feature. Another feature. So there's all these different features with borders. But we actually want to have one continuous field. We want to know from the whole of the Netherlands which area has more or less potential employees for us. And therefore, we are going to convert this vector layer into a raster layer that's also easier to make some operations on. So let's start here. Raster, conversion, rasterize, vector to polygon. And indeed, we want to rasterize this input layer, our neighborhood map. The field to use for a burn-in. So what field does each cell gets? It's the one that we calculate ourselves, the personnel density. The units, we want it to be map units because we wanted to make it hectares, 100 by 100. And the output extent, we want to cover the whole of the Netherlands. So we're going to use a layer extent. And which layer do we have here that actually shows us the whole of the Netherlands? Well, for sure, this one. Okay. If there's no data, it gets 0. So no data meaning no employees. It's fine. And finally, we save these to a certain file, into results, and then we call it personnel raster. Save and run. Takes a while, and we are done. Let's have a look. Yes, this is great. It ranges from 1 to 215, and these are all these nice raster cells. Okay, fantastic. At this point in time, when I created the assignment, I noticed that using these 100 by 100 meter grids, it was huge. It took a long time to calculate the following steps. So what I did for you, I've created coarser raster, and let's continue with that coarser raster. So there's a link here. So if you click on this link, you could also go back to the table and change the area to divide by a 500 meter by 500 meter for the density. But I felt it was easier that I do it for you. How do you download this? This is interesting because this is my own Dropbox, so I don't see what I expected to see. Let's try here. Cognito, put it here. Then I got, yes, this is what we expected to have. Here we go. So now we can download this raster, direct download, and it should ask us where do we want to put it. It's perfect. And we put it in the same folder as the rest of our data. So it was tutorial, warehouse, and I'm going to put it inside results, and I'm going to put it here. Save. Close it. Close it, close it, and this one goes away also. And so we're not going to continue with this one, but we're going to add. So add the raster layer here, and we're going to look for the raster layer in a location, results, and it was called personnel 500. Open, add, close. Here we go. So we can compare it with the previous one. So let's have a look. Let's change it here. So the personnel 500, we're gonna change it to pseudo color. Some nice ramp blues, apply, okay. And the other one, we're gonna make it also pseudo color and to nice reds, apply. So this was our personnel 500. Sorry, this is our personnel that we calculated, so 100 meter grids, and this is then our personnel 500. As you can see, areas with a lot of people are still areas here with a lot of people, and areas with not so many people are still here areas with not so many people. So it's coarser, but if you think of like 40-kilometer radius or ranges, it will not change the results. So let's continue with this one. We're gonna remove this one. Okay, and then the next step is that we are not actually interested, if we place a warehouse here, we're not actually interested in how many people live in this cell. We're actually interested in how many people live in the neighborhood. So in a region that can access our warehouse to come and work for us. So we don't care about this cell in particular, but we care about the population live in all the neighboring cells. And how do we do that? Well, we can do that with focal statistics. So in QGIS, that's a grass package called neighbors. Grass neighbors. Let's try it. Yes. So remember, I actually open my QGIS with raster. If you get an error here saying, well, grass doesn't seem to be available, you have to save your work, close your project, and open again QGIS with grass. Okay, so input layer is not our personnel R, because I just told you it takes a lot of time. You can do it, but it really takes a lot of time. You do with personnel 500. And this we don't need. So how many people we want to have in our neighborhood? That's a sum. And how big is our neighborhood size? Well, we said that people were willing to travel for 25 kilometers. So we have to choose here a neighborhood that would represent these 25 kilometers. This is actually one of the questions in the tutorial, so I'll not go too much into detail. But I'll do something here that does represent 25 kilometers. Use circular neighborhood. It's nice that we have really like a circle, but not a square. This is all fine. I think if it's not fine, you will tell us. Let's save to a file. And what we have now is neighbors, personnel, neighborhoods, and it was the 25K kilometers. Save, and let's try it. Looking good. If you're using the 500, this should take a few seconds. If you're using the 100 meter grid, this should take half an hour or more. Okay, I think it's fine. It's finished. Close. Let's have a look to see our results. Close this one. Let's go back to the Netherlands and turn off a few things. This one. And then neighborhoods, and definitely this one. Yes, okay, this is great. So now we have each of these cells represents not actually the value on the cell itself, but actually how many people live within the 425 kilometer radius. So now we have already our first criteria. Cells which has the most amount of people in a certain neighborhood. That's great. Now the second criteria was actually I want to be close to employees, but I also want to be close to my clients. So my clients are represented by all the shops in the Netherlands in this case, because my warehouse will deliver to all the shops in the Netherlands. and I will consider, so the shops here are point data, but I will consider, let's have a look at it from an open attribute table. I will consider that bigger shops will order more from me than small shops. Okay, this is assumption. You can make your own assumptions. But for these assignments, I'm thinking that a very big media market will order more than a corner street, small convenience shop. So again, this is an assumption, but if you have a different data set with specifically your clients, you should use that one. In this case, we're going to assume, okay, we have all the shops. So gebruiksdoel, so function is a shop. And you have the size, the floor space, oppervlakte. That means 78 square meters. This is 300. So I'm assuming that 600 square meters will order more than a 300 square meter. You can create your own assumption. You can even make different formulas here, but I'm going to assume that for now. So I want to be closer to I want to maximize my proximity to floor space. That's how we can see it. To do that, the easiest is again to convert this point data to a raster. Let's do that. Raster conversion, rasterize. Now we have the retail. Which value I want to put in on the raster cells? The floor space. There we go. But I don't want it to be 1 point for one cell. I want it to, when there's multiple points in one cell, I want you to add it. So you go down here to additional command line parameters and you type in the command add. This will tell the tool, okay, if you have multiple points, you can add their value. Raster size units, that's definitely the map units. Then horizontal is 100 again, 100. Output extent, we're going to choose the whole of the Netherlands, which in our case is represented by regions. Okay, we can also choose the other one, the map we just made, but this is also easy for now. I see everything is complete, and now we save it to a file, and we say what's it's our clients, is our yeah, we can call it clients raster. Oh, wait a second. We just agreed that we would not use 100 meter by 100 meter grids, but we're gonna do 500. 500. And also 500. So it's good that the raster cells have the same resolution for the analysis when we try to compare them. And 500 horizontal, and it should be 500 vertical. 500. And again, we should save it to a file. And we call it clients 500. Okay. And run. Looking good, except for the fact I call it clients 500 instead of clients 500. Okay, we're done in 10 seconds. Let's have a look at our map. Let's turn off this retail. This one also. So let's move in here. And when I turn it on, so wherever there are clients in 500 meter cells, you can see them. When there's none, then you got a 0 or a no data value. Okay, so very powerful. So every raster cell, so how much floor, now we have a raster cell that says how much floor space, let's put a nice color, how much floor space is there in each 500 by 500 meter grid cell. Let's choose a nice color here. This one, we're gonna make it purple. We have a purple. this one we're gonna make it white, and that's it. Can I do this? Now delete all these different gradients. Yeah, okay. Okay. Yeah, so most of the values are white, and this one we can see better. And I'm gonna zoom to this layer, zoom to layer. Yeah, so some areas have a lot of floor space, and most of the areas they're just white. Okay, but again, we don't care about how many people, how much floor space we have in one cell. We want to reach, we want a location where we can reach, we want to maximize the floor space within 40 kilometers. So how do we do that? We do it again with our neighbors tool, where we say our clients 500. We say we want to sum the floor space, and we want to maximize the, we want to add here 40 kilometers. Think for yourself a little bit what is the value you have to put in here. Remember, this is neighborhood size is in the units is in raster cells, and the raster cells are 500 meters. So how many 500 meters do we need to have for 40 kilometers? Okay, I'm going to put in here a value, but you have to think for yourself what value do you need here. Use a circle in neighborhood, and I think this is it, and we save to a file, and we call it, this time we call it clients in 40 kilometers. Save, run. Takes a little bit, but I'm happy we are not doing this in with a 100-meter raster cell. I'm gonna pause and continue when it's done. Oh, here it comes. That's it. We've done it. This is so each one of these cells now represents not how many floor space there is, but the floor space within 40 kilometers. Again, let's give it a very nice color here, pseudo color. We're gonna choose a nice ramp, something like, let's do this one. So red, we don't want to be there, not so much floor space, all the way up to blue with a lot of floor space. Okay, now we have our second parameter ready. So we had already our personnel, if you remember. Now we have our floor space, and we can already see where it's best or not, or worse to be in. And the last one we're gonna do now is the distance to the road network. Okay, for the road infrastructure, we have available to us a data set that I downloaded from Rijkswaterstaat, so the road authority. And here it is. Let's bring that to the top. I'm going to close everything, roads to the top. Okay. So what we have here is a vector data set. But once we make the distance will be a surface. We want to know for every point in the Netherlands, actually North Holland, but we'll come to that in a second. What is the distance to the closest main roads? And these are all the national roads, main roads, and provincial roads. And we just want to have the main roads. The first thing to do is to have a look at the attribute table, and there we have it. We have the name of the roads. So AN204, 915. But you also have the manager, the authority responsible for that road. And I know that P is for province and R is for Rijkswaterstaat, so the national authority. And I only want to know, I want to get the national roads. So let's select that. So we go here, select feature using the expression, and you choose then the fields. The manager, beheerder, is get all unique values. P or R is R. That's it. Select features, close. Now all the R features are closed. And there it is, the network of only the main roads. I'm gonna again create a new layer just for this and say save selected features as. Now I call it main roads, and I say okay. And now I have here just the main roads. And this is the one I'm gonna then to create a distance from. So what do I have to do? I have to convert this to a raster, and then in the raster I can calculate distances. Conversion, rasterize, our old friend. Which value do I want to put in there? Actually, I don't want an attribute from there. I just want it to be 1. So 1 will be there's a road, 0 there's nothing. So 1. Output raster cells units is going to be georeferenced units, and the size is again 500 by 500. All the same. And for output extent, here we're going to do something smart. We're going to use a layer extent, and we're going to use the same extent as one of our other criteria. So I have the same extent for all criteria. And that was the client's 40K, for example. Let's say okay. And then I save it to a file, and I call it roads, main roads raster. Save. Run. We're done. Let's have a look at it. Yes. So as you can see, we had our roads here, and now we have a raster representing these roads. And here you can really see well and appreciate the difference between vector and raster data sets. Yeah. Okay. Now we don't want just where are the roads, we only have the distance to the roads. And for that, then we have what we called raster distance or a proximity analysis. And our input layer is our raster roads. Our distance units we want to have in meters. What is the distance? No data. And I think let's try this one with just all default parameters and see what happens. And we say roads dist. Save and run. Okay, this looks great. Let's change the symbology into single band pseudo color. Apply. So red is very close, blue is very far. But actually it doesn't make sense to have things here on the ocean. So let's make this better looking. We just care about in the Netherlands. So we're gonna clip this raster. Clip raster by extent, clip raster by mask layer, this one. So we're going to say rows distance. I want a mask layer, and my mask layer will be the Netherlands. Where is it? Regions. And everything else is the same. Yeah. And now we're going to say roads dist. And save and run. Okay, turn off the other one. This looks better. So 0 became black, and it goes up to 38 kilometers. Change the symbology, single band, apply. Looking good, but actually I don't care about all these zeros here. So let's just give between 1 kilometer, because 0 is actually on the road, and apply clip out range values. So if I do this, clip out the range values, and I say I want to start at 1, apply, and okay. There we go. A new data set with let's change this to compare it better. Apply, and it's not. We're gonna make it into quantiles. Apply. No, into intervals. So a few more classes. Apply. Yeah. So now we have distance to the main roads. We can already see that in the islands here we'll have more distance than in the mainland, but also here we see here will be worse than here. Okay, so now we have the 3 criteria: distance to roads. The other one was our clients, and finally our the personnel in 25 kilometers. Now with our 3 criteria, we're ready for our multi-criteria evaluation. But we remember, we don't want to know anywhere. We want to specifically know in certain industrial sites. So let's take that into account also. We just want the cells that are located in industrial sites bigger than 50 hectares. So for that, we're going to take our industrial sites bigger than 50, which is here. We're going to also rasterize that. We want to give it use a field. No, we just want it to be 1 if it's an industrial site. Where is it? Industrial sites. Yeah. Bigger than 50, it's going to be 1. Your reference units is going to be 500 by 500. Output extent. We want it to be our, doesn't matter too much, but it's good to be consistent regions. Okay, and finally we have then here Indust 50 plus raster. Save, run. We close. Let's have a look to see what happened. Yes, so here we go. So we represent our industrial sites now by raster cells. Let's bring everything together. So the proposal is that you go to raster calculator, and then you're going to do multi-criteria evaluation. This is when you combine the 3 layers. Let's first do it very simple, just for the sake of it, for understanding. We're going to now combine. We're going to say, okay, I care about being very close to clients. Actually, I have to deliver to them, so the closer I am to the clients, the better. So this is our first criteria, clients. But the clients, if you remember, they're now in floor space. So how many square meters there are in this floor space? And actually, that's not exactly what we want, because we cannot compare floor space with personnel, which is in people, with in meters, which is for the distance. So we have to standardize this data. So let's first standardize it. We're going to standardize everything from 0 to 1. And 0 means it's not a location I want to be in, and 1 means this is best for this criteria. How do you do that? So the best is to divide by the max. So our first criteria then is personnel. Let's go. Where is our personnel? Here it is. And if we look here, we can open it and we go to information. What's the max of this value? Here it is, maximum. This is the maximum value we have. So we want this one to become 1 and all the way to 0. I'm going to copy it. Okay, I go back to raster calculator, and this is our personnel within 25 kilometers. I think it's this one, divided by the max. And I'm gonna put it in here. See, temp, tutorial, warehouse results, and now I'm gonna have personnel 0 to 1 and go for it. Brilliant. So as you can see, it looks exactly the same as the other one because it is the same values, but it ranges between very small number and 1. But the data, relative to each other is the same. So we have our first 0 to 1 layer. Now we go for the second one, which is the, what's it called? The clients. Let's go and look what is the maximum of our clients. Clients 40K, properties, maximum value is this one. These are floor space within 40 kilometers. Okay, and then raster calculator, clients 40K divided by our maximum value. We give it also a number, a name, clients 0 to 1, save, diff. Okay, yeah, great. Next one, the next one is the roads. The roads is peculiar because actually in the roads, distance to roads actually, we actually want, where is our distance to roads flipped? That doesn't matter. Our roads, we want a small value to be 1. I want to maximize my proximity to roads. And if I'm very far away, that should be my 0. So we have to think of a way to do this when we scale it. Let's look at again where is our clipped version? So I think it was roads distance NL. Here it is, roads distance NL. And let's look at the properties for the max value again. The max is this one. And we go to raster calculator, and our roads distance NL divided by the max. But if we do this, then the very far away number becomes 1, and the very close number becomes almost 0 or 0. So we don't want this, we want to invert it. So what will be the easiest way? See, this is also a question there. There's other ways of doing this. This is one way of doing this. Think about it a bit for yourself. What is the best way of doing this? Now we have roads distance 0 to 1, where 1 is best and 0 is worse. Let's have a look. Roads distance, and indeed symbology, pseudo color. Let's do it with the nice greens, where 0 is worse and dark is good. Okay, and there we go. We have now closer to roads. You see here, it's darker, closer to 1. Brilliant. Okay, now we have it. All our criteria between 0 and 1. Now we have apples with apples instead of apples and pears. So we can then do our multi-criteria evaluation. Raster calculator. The first one is our clients 0 to 1, plus our personnel 0 to 1, and then plus our This is to roads 0 to 1. But actually, I care, so be close to clients. That's for me really important. So I want to give it a weight, and that is like really important. So I'm going to represent that by giving it a proper weight. And personnel, also important. So I'm going to give it a weight 0.3. You have to think about this yourself and choose your own weights and justify them. 0.2. So here 35, and this one 15. And it's good that you justify this. So if you say, well, actually, being close to roads is really important because I can put in a big billboard so people can see it from the road, then you give a huge weight to this one. Or if you say, well, actually, I don't think being close to clients matters so much because in the future all my trucks will be electric, so I don't pay anything for a kilometer of my trucks. So you can give it a lower weight here. And I really care about having a lot of personnel, and you can give it a higher weight. Or you can say, well, in the future my warehouse is fully automated, I don't need personnel. You can lower the weight here. So think about these weights and try to justify them. And I'm just going to do this like this for now, for us to have a look to see what's happening. And then we could add more variables here. So remember the constraint, the industrial sites. But let's wait a second before we include that one. And I'm going to call it just the criteria summed. Actually, a weighted linear combination. That's actually the official name for this weighted sum. Save, and I'm gonna run it. So something very powerful is doing is going through each and every one of the cells and then multiplying that by the weight and then summing them up with the results of all the other cells. So it's combining the 3 different rasters into one raster of criteria. And I think it would be nice for us to get the feeling what would be the best areas and less suitable areas for us to locate our warehouse. This is for the whole of the Netherlands we're doing now. Almost there. Yes. So now we have a very good feeling where our locations, the best locations will be. But there's some variation here. So here is better, there. Let's try to give it a nice, where is this one? It's called, this is the weighted criteria, yes. Turn off everything else. Let's change the colors, blue band. And now we actually think it's better and worse. So it makes sense something like this. Worse is red, all the way to 0.9. And 0.9 means it scored almost the top score in all criteria. Why? And okay. Now we have our multi-weighted criteria. But remember, we cannot do this everywhere. So we have to then just select the areas where we can do this. And that was represented by our industrial bigger than 50 raster. Yeah, so we only want to have data on these values over here. So again, raster calculator, and we say our result of the criteria multiplied by our zeros and ones from our industry sites, and we say the multi-criteria evaluation. Okay, so if a big number multiplied by 0 gets 0, if any number multiplies by 1, I can do it there, keep the same number. Okay. This takes a while because it's multiplying all the numbers. I'm going to pause and come back when it's done. Okay, here we are. We've succeeded. We have our final map here. There's still a nice range of alternatives. Our MCE goes from 0.1 all the way to 0.9. Let's give it some nice colors again. Single band, same. Okay, and we're gonna remove this one, and we're gonna remove this one. Here we go. Now we have the locations of the warehouse or of the industrial sites, and blue is best and red is worse. But we don't want to look at it from a raster perspective anymore. We want to see the real sites. And I think they're still here. So I think it's this one. Yes. So what we want to do is update our polygons with the value of our raster. So then we have it on our attribute table. And how do we do that? So how do we calculate a certain value of a raster into a zone, a polygon zone? So what I just said, so zone will be the zonal statistics. Raster layer zonal statistics. And I'm gonna say that I want to calculate the statistics for this final, the MCE, and I want to update my industrial west 50 plus. And which kind of statistics do I want? Well, actually, I don't want, you could think of the average, but I just want, okay, what is the site? What is the best location? So this all will lead to very similar results, average, some not, but because the more you have, the more you get. But definitely the mean, but I think the max will represent better what we're looking for. It's up to you to decide. Now I'm going to say okay and run, and it's done. What happens now is our industrial sites, if we go to open attribute table, it is now the mean value, but also the max value, so of the cells included in this industrial terrain. Let's do that. Let's sort it by size. And now here, if I do this, and if I do here zoom to selection, here we go. The 3 sites that score highest in our multi-criteria evaluation. Now you could think of, well, they're actually not so far from each other, so I actually want not only these, but I actually really want a site here. What's the best site in this neighborhood, this region? So then you could determine that again, making selections. And you've selected 3 alternatives, and then you should export our final map. So you can also select other locations. I right click on it and say export save selected features as. And this is our C results temp tutorial warehouse results final 3 run. And the proposal is that you should make a nice map with these final locations. So you can, for example, think about open attribute table, start editing it, add a new table, add a new field called rank. And then which one is the highest one here? 926. This is number 1, number 2, number 3. Save it. Stop. Oh. Number 3. Save. Stop. And now we can even label this. Single labels based on our rank. How does this look like? Bigger. And yeah, so let's take everything else. and we make it nice. We actually, it would be nice to see the roads actually, not to give a feeling. Let's put in the region. Let's put in the roads. So we have a feeling where it's located. Oh, these ones are actually very close to the highways. Very nice. And you can think of other things. This is it. So make a nice map and paste it on your report.